All right, so what we have here is a parabola. It's just not written in the way that we want it to be written in because we can't clearly identify the vertex just yet. But here's what we do want to be able to see. We have x squared. So we know that's going to be a parabola that opens up or down. Identifying which one is your square is good because that's the piece that we're going to complete the square for. So if you remember completing the square, you need to move away any piece that is not connected to what you're working with. So we want to take the x's, so x squared plus 4x. We're going to leave some space, and we're going to move the other terms to the other side. So minus 6y plus 26. And our goal is to take what's here on the left and factor it as something that's a square. Now, if you remember completing the square from the college algebra days, shouldn't be a problem. You take half of this coefficient, so half of 4 is 2, so it goes plus 2 right here. And then when you square that, you get plus 4. So it's the plus 4 in that gap that allows me to take what's on the left side and factor it as the exact same two factors, x plus 2 and x plus 2. Now notice I like to use colors, right? So since I added 4 on one side, I have to add 4 on the other side. Otherwise, I've changed the problem, and it's not equivalent to the original. So let's clean things up. On the left, we have negative 6y plus 30. So we're almost in the form that we want to see for a parabola. X plus 2 quantity squared. On the right side, you want to factor out the coefficient of y so that you can clearly see what the y, in this case, what the y coordinate of the vertex is. So factor it out, and you get y minus 5. All right, so as we said before, we do have a parabola that opens up or down. And because this is a negative, it tells me that we have an upside down parabola. So let's scroll down here. We have a parabola that is opening upside down. Let's start off by finding that vertex. So the vertex, the x is going to come from what you see here with the x, so it's actually the opposite. So negative 2. And then the opposite of what I see here, so positive 5. So this is negative 2, positive 5. I now need to figure out what is the difference between my vertex and the directrix, and then my focus. Now understand, this picture is definitely not going to be to scale. It's definitely going to be off, but again, it's all about understanding the concepts. So for a is equal to negative 6, which means a is equal to negative 6 over 4, which is negative 3/2. So that's the distance between my vertex and the directrix, and between my vertex and the focus. All right, so in the previous videos, we've been finding the focus first. So because of the orientation, the x-coordinate doesn't change. It's still negative 2. But now we're going to take 5 and we're going to subtract the 3/2 because we're going down 3/2. Remember 3/2 is just 1.5. So 5 minus 1.5 is going to be 3.5. No big deal. For the directrix, it's that horizontal line y equals. So we go from a y value of 5 and we're going up 1.5. So that makes it 5, 6.5. So we can say 6.5, but I really don't like seeing that in an equation, so it would be better if we saw this as 13/2. All right, and then we have our axis of symmetry. It's that vertical line because of the orientation here. So vertical line that goes through these guys, and that is x equals negative 2. All right. So my focus, we said, was negative 2, 3.5. All right. Now let's talk about my domain. As I mentioned in the last video, if you've got x squared and you have a parabola, your domain will be all real numbers. And since we have our picture, the range should be pretty easy to identify. It's coming from negative infinity, and it maxes out at a y value of 5. So 5 with a bracket. All right, now we identify those endpoints for the lattice rectum. All right, so it's going to be these two guys right here. So our A value was 1.5, which means when we do the lattice rectum, we double that to get the change on either side right here. Because as we've seen before, the distance of the lattice rectum is going to be the same thing as what we have here for 4A, but the absolute value of that, so 6. All right, so since that distance is going to be 3 between the vertex and these endpoints, you're taking this guy right here, and you're going to be adding and subtracting 3 to the x because you're moving left and right. So if I add 3, I'm at 1, 3.5, and if I subtract 3, I'm at -5, 3.5. And we already knew the distance of the lattice rectum, so we're good. The key thing in this problem, though, is making sure that you can take the original equation, recognize that it's a parabola with x, complete the square, and then factor so that you can make sure that you can clearly identify the vertex. All right, so let's try this again. With a different problem, of course. If I take y squared minus 10x minus 10y minus 55 is equal to 0. All right, so I see here that I've got y squared. And when we're talking about parabolas, you're only going to see either x squared or y squared, not both. If you have both x squared and y squared, we could have a circle or an ellipse or a hyperbola. It just depends on a few other conditions, but we'll get to that in a later video. So since the y is being squared, we want to put all the y stuff together. So it's going to be y squared, and this is still -10y. As we did in the last problem, leave a gap because we have to complete the square, equals, and move the x and the constant to the other side. So it's a positive 10x and plus 55. All right. So when we complete the square, we're expecting this to become a binomial squared. To figure out the factorization, you do half of that coefficient. So that will be -5, and you square that to get a positive 25. It doesn't matter what you have in the parentheses. When you complete the square, this is always going to be positive, because whether you square a positive or a negative from inside here, that guy's going to be a positive. But remember, what you do to one side, you have to do to the other. So we got to do that on the other side. So this is equal to, let's see, we've got 10x. 55 plus 25 is 80. And as we saw in the last problem, take the time to factor out that coefficient of the variable. So factor out the 10, and I'm left with x plus 8. Okay, so now we can focus on this equation. You've got y squared, and this is a positive number, which means that we have a parabola that is opening up to the right in the positive direction. So y squared tells me it's a sideways parabola, and the positive tells me we open up to the right. So let's find that vertex. So the vertex will be the ordered pair. Again, it's x and y, so do the opposite of what you see here with the x, -8, and the opposite of what you see here with the y, +5. And like we've been doing over and over again, find out what a is. So 4a equals 10. A is equal to 10 over 4, which is 5/2, or 2.5. So that means with my focus here, my directrix there, the distance between these two will be 2.5 units. All right, so we have, let's see, this is -8, 5. Let's identify the focus. So the focus is shifted, or it's 2.5 units to the right of the vertex. So if I add 2.5 to this, I like to do this in parts, right? So if I add 2 to -8, I get -6. If I increase that by 1/2, that's -5.5. And the y value stays at 5. All right, so -5.5. 5.5, 5. My directrix is the vertical line, so it's x equals. If I'm at x equals -8, and I go to the left 2.5. So go left 2, that's -10. Go another half, that's -10.5, which is -21.5. All right, and let's find the axis of symmetry. Axis of symmetry is this horizontal line that goes through the vertex, goes through the focus, it's perpendicular to the directrix. So here it's y equals, and the y value that's constant as you go across, y equals 5. All right, now the last part is the lattice rectum. As we keep seeing, this is A, but the distance between the focus and one endpoint is going to be 2A. So it means I'm going to be going up 5, I'm going to be going down 5. So the key points for the lattice rectum, I skipped domain and range. We'll come back to that. Key points for the lattice rectum will be x is still -5.5, but we're going to go up 5, so it's going to become 10 for the y. And then we go down 5, which makes that 0. And of course, the distance of the lattice rectum is the same thing that you see right here. It's just going to be 10. Now, the things I forgot to do, and I was going to forget something, is identifying the domain and the range. Okay, so if it's y squared, it's the range that is all real numbers. For the domain, we look at the picture. We go from left to right, starting on the left with x is equal to -8, and then going out toward infinity. So there you go. Every problem that we do, it's the same. There's not really much that's changing here. You draw the vertex, you draw the parabola, get the right orientation, and you can answer all these questions. And a lot of it comes down to figuring out what is A. So once you get that, you'll be good to go.